Dear students, in this video, we'll start integration in mechanics. Remember that S equals V times T. Displacement equals velocity multiplied by time. If you remember this formula, you will always remember that S equals integral of V dot dt. As we explained before, the start of this lesson, and I made some steps, you remember? Remember the units of measuring and you'll never forget the formula. A particle moves in a straight line so that its velocity v meters per second at time t is given by v equals t cubed minus 4t. Find an expression for its displacement from the initial position at time t. V equals t cubed minus 4t. And we need to find the displacement. Displacement is integral what? Integral of velocity with respect to time. We have two options. Either we don't have limits, so we just increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power, and see. But if we have limits, we increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. No C. Let's do both. The first method is S is integral, open brackets, write the formula t cubed minus 4t dot dt. This is an algebraic expression in terms of t, and here is t power of 1. So S is equal to t power 4 divided by 4 minus 4t squared divided by 2 plus c, and we can simplify it. So S equals t power 4 divided by 4 minus 2t squared plus c. We're done. You tell me, Miss, but we have to find the value of c. Yes, we should find the value of c. We know a good information that at the beginning of the story, time equals 0 and the displacement is also 0. So C will be 0. If you substitute for t equals 0 and s equals 0, the constant of integration will be also 0. So s will be t power 4 over 4 minus 2t squared. Full stop. Remember to put in brackets and put the units of measuring. Now I'm done because we don't have limits. But there is another method. If we have limits, I can do it like that. S equals, it looks like an integral sign. S equals integral of t cubed minus 4t power 1 with respect to time. And the limits will be from 0 to time t. In this case, if we have limits, we don't have to mention the constant of integration. So now S will be, we'll put the answer in box brackets and increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. No C, and we write the limits of integration on the box brackets. So the answer will be finally the same, which is t power 4 over 4 minus 2t squared measured in meter. Next, a particle moves in a straight line so that its velocity v meters per second at time t is given by v equals t cubed minus 5t squared. Part A, find the displacement of the particle after 5 seconds. Part B, we need to sketch the velocity time graph from from 0 to 10. Expect the shape of the curve. It is a cubic function with humps. Work out the distance that the particle travels in the first 10 seconds. Take care, the distance is adding the displacement, because sometimes there is displacement in opposite direction, which is negative. So you take the magnitude, you take the absolute value, and then add all displacements as positives. Work out the distance, part C, work out the distance that the particle travels in the first 10 seconds. Okay, part D, find the time when the particle passes through the start position. Let's start. First of all, he gave me velocity in terms of time, which is an algebraic expression. And now we'll find the displacement of the particle after 5 seconds. So part A, S, we'll say S is integral of V dot dt. So S equals, if you don't want to mention the constant of integration, you can take it directly from 0 to 5. So it will be integral from 0 to 5, open brackets, t cubed minus 5 t squared dot dt. Increase the power by 1, put in box brackets, increase the power by 1, t power 4 over 4, divide by the new power, minus 5 t cubed, divide by the new power. No c, because there are limits of integration. Okay, when you substitute, of course, you know the method of substitution. You just substitute in the first box brackets by 5s and the second box brackets by 0s. This is the, I know it will consume time, but this one I just say it, and after that I'll give you directly the final answer. Remember, there is a button, the calculator, which integrates, substitutes, and subtracts and give the final answer. You put here brackets, power 4 over 4 minus 5 brackets cubed over 3. Repeat, brackets power 4 over 4 minus 5 brackets cubed over 3. And substitute here for 5s and here 0s. Of course, this bracket will give you all of it, it will give a 0. And when you calculate, the final answer will be negative 52.1 meters. This is part A. Part B, we need to sketch the velocity time graph from 0 to 10. First of all, we have to put velocity time graph. We have to put V equals 0 and find the values of t, because we need points of intersection with x-axis, but now we call it t-axis, so points of intersection with t-axis. Now here's x-axis, and first of all, before we do it, we should calculate. Now put V equals 0 to find points of intersection. It will be t cubed minus 5 t squared equals 0. Don't divide by the variable, but take it out as a highest common factor. So we take out t squared as a highest common factor. Here is t minus 5 is equal to 0. We have two values, either t equals 0 or t equals 5. It means we have an instantaneous stop twice in this journey. At the beginning, of course, because we started from rest, and after 5 seconds. So remember, when we took sketching curves, that sketching the cubic function, which is the positive x cubed, if this is x-axis and y-axis, this is y equals x cubed. This is the, it should be an increasing function, but in this case, it is having humps. So, of course, t-axis has no negatives, and when there is a perfect square, I'll highlight it to remind you, when there is a perfect square, it means there is a repeated root. So t equals 0 is a repeated root. Expect that the graph, that the curve touches x-axis, touches t-axis at t equals 0 and cuts x-axis, which is t-axis here, at t equals 5. I remind you, here the curve touches t-axis and here the curve cuts the t-axis. This is t-axis and this is v-axis, and because there are units of measuring, we should write here that T is measured in, we should be accurate. My students are all of them accurate. T measured in seconds and V is measured in meter per second, and the curve should be touching and cutting, touches and cuts. So here is 0 and here is 5, and the end of the story at 10. Of course, I'd love to make it exactly in the middle. Here is 5, here is 10. Now the next question, work out the distance that the particle travels in the first 10 seconds. The distance that the particle travels in the first 10 seconds, we will remember that when you integrate, of course, distance is the integral of velocity with respect to time. So when you integrate, this part will give you a negative area. Yes, when we integrate a function, it means you are finding the area bounded by the curve and x-axis. And when the curve lies below x-axis, you have to expect that the integration will be negative. And this part will give you a positive value. So we have to find, these are expectations before we start. So we have to find the absolute value of the negative part and then add it to the positive part. So now we'll divide it into two parts. Work out the distance the particle travels in the first 10 seconds. I'll integrate from 0 to 5. This is part C. Integrate from 0 to 5 velocity with respect to time, and integrate from 5 to 10 velocity with respect to time, and I'll add both. I'll have to turn over, and now we'll find part C. I'll name it S1 is integral v dot dt from 0 to 5. And let's go. S1 equals integral, open brackets, what was the formula? T cubed minus 5t squared. Oh, I'm done before. We did it before. It's t power 4 minus 5t cubed over 3. And even we did already the from 0 to 5, so don't repeat it. From 0 to 5 is already done, negative 52.1 meters. Now we'll start to integrate the next part, which is from 5 to 10. Negative 52.1. Actually, it was negative 52.08. And the next part is S2, the next displacement from 5 to 10 of v dot dt, which we already got it, but we'll change the limits on the box brackets. You remember the box brackets? What did we write in them? It is t power 4 over 4 minus 5 over 3 t cubed, and you have to change the limits on the box brackets, which will be from 5 to 10. And after substitution, subtraction, you will get 885.42 meters. Now, in order to find the total distance, it will be the absolute value of S1 plus S2. It means consider the value of the magnitude of the displacement, which is 52.08, and add 885.42. So the total distance will be 938 meters, and usually we give our answer correct to 3 significant figures. Now let's read the last part. Find the time when the particle passes through the start position. The time where the particle passes through the start position, it means I need to find the time when displacement equals 0. Displacement equals 0, so we just equate this expression. Can you see my yellow highlighter? I'll make it green. This expression, I will equate it to 0. Let's go. So part D, at the start, it means displacement equals 0. So S equals 0, which is t power 4 over 4 minus 5 over 3 t cubed equals 0. The best thing to get rid of both denominators is to multiply both sides of this equation by 12, because 12 is the highest common factor of both 4 and 3. So this one, the first term will be 3t power of 4. The second term, cut, then 4 times 5 is 20. T cubed equals 0. Remember not to divide by the variable t. So we can take out t cubed. We take out t of least power. Take out t of least power as the highest common factor. So here 3t minus 20 is equal to 0. I have two solutions. Either t cubed equals 0, which means t equals 0, or t equals 20 over 3. What does this mean? It means at the start, this is the point O. At the start, we moved backward. Remember how much? Negative 52.08 meters. Negative 52.08 meters. And then you moved forward 885.42 meters. But we're not discussing this thing now. We are discussing what does this mean that we'll pass by point O twice. We will pass by point O once at the beginning of the story, which is t equals 0, and another time at t equals 20 over 3 seconds. 20 over 3 seconds. 20 over 3 seconds, it means 6 seconds. It means after 6 2/3 of a second. Okay, that's all for this video, and we'll continue in the next video, integration in mechanics. Bye-bye.